Hey Peacock! In this video I'm going to be showing you how to use sum and difference identities to prove trig identities. So the first proof we're going to do we're going to prove that cosine of x minus y minus cosine of x plus y equals 2 sine of x times sine of y. So right off the bat, right, we're going to start with the left side, and right off the bat we are adding two angles and subtracting two angles. So we know we want to use the sum and difference identities. So I'm going to start with the difference identity for the first one. Because we're doing the same identity, or same, I guess, type of identity, we can do it all in one line. So cosine difference identity will be cosine of your first angle, so cosine x, right, times cosine y, and then it's plus sine of x times sine of y. So that is this first step. Then I'm going to bring down my subtraction sign and in parentheses do the sum identity. So that'll be cosine of our first angle, so cosine of x times cosine of y minus sine of x times sine of y. And because this is a proof, make sure you write the reasoning. So that's just the sum and difference identities. Now at this point we have a lot going on. It expands a lot. So I'm going to distribute this negative. That's just algebra. So cosine of x comes down, cosine of y, plus sine of x times sine of y. And then this distributes, so for the first term it would be minus cosine of x, cosine of y. And then this, because it also gets distributed, will be positive sine of x, sine of y. And that is just algebra. Alright, and now I'm going to look to see, again, it's kind of a lot going on, but we do have multiple terms, right? So we have cosine x, cosine y, and then over here we have a minus cosine x, cosine y. So these two are going to cancel, if you want, just for a visual. And then I have sine of x, sine y, plus sine x, sine y. So if I just add those two together, I'll have 2 sine x, sine y. And that is exactly what we wanted. So our proof is over because we just did some algebra. So that's one kind of example you could have for proofs. Another kind of example is this. We're going to prove that cosecant of pi over 2 minus theta equals secant of theta. Alright, so the difference here is instead of just having x and y, we have an actual angle, and then we still have, like, theta, remember, it's just like x or just like y, it just represents the angle that we don't know. So we're going to start with the left side and prove that it equals the right side. And I'm going to start by using my reciprocal identity because this is cosecant and the sum and difference identities are for sine, cosine, and tangent. So I'm going to first change this to be sine. So 1 over sine of pi over 2 minus theta. And that's just the reciprocal identity. Now that it's in terms of sine, I can use my difference identity for the sine function. still remains in the denominator, so it's 1 over, and it will be sine of pi over 2 times cosine of theta, right? Sine of first, cosine of second, minus cosine of the first angle pi over 2 times sine of our second angle theta. All right, so that's all in the denominator. That was the sum and difference identity. Okay. Now what I'm going to do is evaluate. So I'm going to do sine of pi over 2. So I'm thinking, okay, on the unit circle, at the angle pi over 2, my y value is, hopefully you're thinking 1. Hopefully you don't need to use your unit circle anymore. So that's just 1 times cosine of theta. And then cosine of pi over 2, this is your x value at the angle pi over 2, which is 0. Right? So that was evaluating. We just evaluated these trig functions. And now I'm going to simplify. So this just becomes cosine. This will be 0. So we're left with 1 over cosine of theta. Right, that's just simplifying, so just algebra. And 1 over cosine of theta is the same as secant of theta. And that is based off the reciprocal identity. And we are done. So sometimes with these, you're just going to have to combine and simplify. Sometimes you're going to have to actually use your unit circle to evaluate.